example, we're going to show what happens in the case where you may have to use, or it may be more convenient to use, representative rectangles that are horizontal. So I've got the two equations, x equals 4 minus y squared and x equals y plus 2. And you notice they are both solved for x instead of y. So you have to be a little bit careful with this when you make your xy chart because you want to actually plug in for y. So when I graph those, I get the following. And I can see that my region is going to be this one right here. Now, if you were trying to solve for y and graph and do this using integrals on x with vertical representative rectangles, then you would run into a problem because you switch from this graph being the higher one to this graph being the higher one at this point x equals 3. So in this case, these horizontal rectangles are actually easier, and you can see the way that they're built is from one curve to the next. And the nice thing about this is x equals 4 minus y squared is the greater of the two x values for every point in that region. So I'm going to start by finding the bounds. So 4 minus y squared will be equal to y plus 2. And if I solve that for 0, I get y squared plus y minus 2 equals 0. And I can factor and get y plus 2 times y minus 1, which gives me y equals negative 2 and 1. So that's going to be my bounds from negative 2 to 1. And we're integrating with respect to y. And the rightmost function is 4 minus y squared. And the leftmost is y plus 2. So that is going to be my integral. And I am going to do some simplification before I integrate. So I'll have negative y squared minus y, if I distribute the negative, plus 2 with respect to y. And that gives me negative y cubed over 3 minus y squared over 2 plus 2y. And that's all going to go from y equals negative 2 to 1. So I will have negative 1 cubed over 3 minus 1 squared over 2 plus 2 times 1 minus negative 2 cubed over 3 minus negative 2 squared over 2 plus 2 times negative 2. And when I go to simplify that, I get negative 1/3 minus 1/2 plus 2. Distributing my negative, I'm going to have minus 8/3 plus positive 2 and then plus 4. And when I add all of that together, I get 9/2 units squared. Now again, you could do this one using vertical rectangles, but it would get pretty complex pretty quickly because you would have to look at this part of the graph being the square root of 4 minus x and this part being the negative square root of 4 minus x if you were to solve that x equals 4 minus y squared. You get y equals plus or minus the square root of 4 minus x. And so your area would be the integral from x equals 0 to 3 of what we get is just the x minus 2 minus the negative square root of 4 minus x. And then from 3 to 4 of the square root of 4 minus x minus the negative square root of 4 minus x. And this is doable, but I don't know about you, the y version seems easier to me. So if you can save yourself a little bit of work by using horizontal rectangles instead of vertical rectangles, it's worth doing.